today's topic, we are looking at it is summations, permutations, and combinations. I'm going to start off with summations. Summations, I think if you remember, if you forgot, please do remember from metric where there was a topic, there is still a topic actually on sequences and series. Sequences and series, there was that chapter that we hated so much when we were doing a metric. So that's what we are bringing to remember. So it's about sigma. That's a notation that is being used for summations. It means sum of. We know what this is a sum of, and I think before I even proceed, I just need to share with you what are the common misconceptions. Okay, the common misconceptions across the three topics, the three headings, that is summation, permutations, and combinations. It is calculations. Okay, you need to remember your basic calculating skills. We will try and help you to remember. And also another thing is substitution. With summation, it is purely calculation. There's nothing much. You don't have to think there. You don't need to think from context. Decontextualization is the problem because you need to read a story and then interpret that story. So it's always problematic. I'm also struggling. Remember, English can be problematic. But even if you are an English person, maths is maths. So that is another problem with permutations and summations is decontextualizing the story. So now with summations, it's only about calculations. So now this thing, the way it reads, it is reading that it is a sum. It is a sum of all terms from the third term here. K is equal to 3. It's like this is your starting term. Your K is equal to 3, and then and it's ending to the fifth term. So now here is an example of expanding. This is all about substitution. Okay, it's substitution. So this means you're going to start with K. You're substituting your first value, your T1, your term 1 is going to be, you substitute into this formula, your K is equal to 3, and then you substitute in an ascending order. So you're going to have 3, 4, 5, and then you just add. Okay, that is the basic theme of calculation. This is what it means. You've got an index. This is your n is equal to 1. This thing is suggesting that you are starting at 1. So your first substituting value will be equal to 1 into this formula. So you are going to have up to 6 terms, you're going to have 4 into 1 because your n is equal to 1 plus 4 into 2 plus 4 into 3 plus 4 into 4 plus this is equal to 4 into 5 plus 4 into 6, because this is your last value n. Okay, that's basically your summation. I did not see anything that would be giving you any sleepless nights there. So what I did was to say, okay, fine, since there's nothing much that we have to do, there is no discontextualization. I'm sorry, guys, I could not get my question papers, but I did try and look out somewhere for some exam questions. So I did include some exam questions, but I don't have the full question papers. But definitely by next week, I'll be having the question papers and the assignments. So now here is an example of a summation. So now here, if ever we are starting here, this is the summation that you are supposed to do. You are starting at t is equal to 0 and ending at t is equal to 3. So this means we are going to be substituting into this formula. We are going to be having your 5k. You are going to be having 5 5 plus square root of x to the power 0, because you have to start with t is equal to 0. Okay, and then plus, and then your next value is going to be 5 plus x to the power 1. So you're writing the full formula. The common error that you can quickly have in the question like this is whereby you only write 5 once. Okay, you only write 5 once and only have plus x to the power 0 plus x to the power 1. So you write the full thing as it is. Okay, as I've done here, 5 is here, the full formula, you write it. So be careful when you are working with the summations. Whatever you find here, you are going to do it for each and every value of your t. Okay, so I'm just highlighting the common misconception and common error that is possible in this question. So this is going to be 5 plus x to the power 2. We have to stop at 3 plus 5 plus x to the power 3. That is your last term. Okay, so what needs to be done from here? It is just to simplify. Okay, let us first simplify, or without even simplifying, you have to find the value of this thing when your x is equal to 4. So now you can just substitute for your x value. So now we are told what your x value is equal to. Your x value is equal to 4. So you're going to have 5 plus wherever there is your x to the power 0, we know is equal to 1. So without even wasting time, any base to the power 0 is equal to 1. So this is just equal to 1. So I don't want to even worry myself by substituting by 4 plus 5 plus, this is going to be equal to 4 plus 5 plus, this is going to be equal to 4 to the power 2. Okay, plus 5 plus, this is going to be equal to 4 to the power 3. Okay, so this is going to be equal to, when you simplify this, you're going to have 5 plus 1. That is your first expression. Here you've got 5 plus the square root of 4. It is equal to 2 plus, here you're going to have 5. If you do this thing by inspection, 4 to the power 2 we know is equal to 16. So the square root of 16 is equal to 4. Okay, this is going to be equal to 4 plus, here you are going to have 5 plus 4 to the power 3. So you need to simplify this thing and use the rules of the sets. We call these rules of the sets. So what you are going to do there, I'll just make a little calculation here, whereby we are saying if ever you've got a value here, which is a to the power n, and then this is equal to m, this is part of our sets, which is part of the bigger topic. That means the discourse of exponents. This is equal to a to the power n over m. I'm already getting into a discourse of our exponents. So remember, we may not have time of reviewing all of these topics, but I will highlight them as we are going along. So now this is a topic of our exponents. So now here we are going to apply that to simplify this. So now this implies Guti, a square root of 4 to the power 3. Remember, every time there's a square root and there's nothing in front, we know what this is equal to 2. That is the basic property of square roots. Okay, and then this simply is equal to, we know into Guti, this is going to be equal to 4 to the power 3 over 2. we know that 4 can be written as the base of 2. Okay, so 4 as a base of 2, this is equal to 2 to the power 2 multiplied by 3 over 2. So this will divide, this will divide. So this is going to be equal to 2 to the power 3, and 2 to the power 3 is equal to 8. Okay, this is basically a way of reviewing basic knowledge on exponents. Okay, so now this square root of 4 to the power 3, it is simply equal to 8. So this is going to be equal to, this is going to be 8. So I think now you can just get your answer, which is going to be 6 plus 7 plus 9 plus plus 13. So this is equal to 35. The reason why I have done all of this question is because I wanted us to review this part. I wanted us to review the laws of the exponents, because that is one of the critical aspects that is being addressed by the question. So now the value of this, when x is equal to 4, it is equal to 35. Okay. The next one, here's another one. Here you need to also evaluate this. That means you simplify. Similar kind of thinking. This question is asking so many critical aspects. It is looking into exponential discourse. Okay, it is looking at the at AMA operations. Remember, if ever you were here last week, we were talking about AMA laws of operations. This is also testing those things, but in one goal. Okay, so that's why you have to be aware of all these discourses. I am very sorry for you guys, because you have to remember so many things. I was looking at all of your topics. I said, this is basic maths, and basic maths is very, very rude, because it wants you to look at the smaller yana things. So you have to remember so many things at once. So I am very sorry for you guys. There's nothing we can do. Let's see how we can help you. So remember, we said one of the common errors that you find with summation, it is not difficult. One is most of the time uh, you only substitute for one value, and then you forgot to do it for all of the values. So here we are starting at m is equal to 1 and end at m is equal to 4. So wherever we see an m, we are going to substitute 1, 2, 3, 4 repeatedly. We are going to have 3 expressions. Okay, so this is going to be equal to minus 1 into 1 plus 1 into 1 squared plus 2 to the power 2 into 1. Okay, so you can see what these are about exponents. There's also a discourse of exponents. So we'll try and see if ever we cannot bring to memory that that discourse. So what I'm doing, I want to protect this because it's a long expression. I don't want to be making any errors. So I'll protect this thing with these brackets. Okay, so this is going to be and then we've got a second expression. A second expression is going to be m is equal to 2. We are moving in an ascending order, so we are going to have minus 1 into 2 plus 1 into 2 to the power 2 plus 2 into 2. Then we close our brackets. Okay, and this is the second one. I need the third one. The third one is going to be, I open my brackets, minus 1 to the power 3 plus 1 into 3 squared plus 2 into 3. I want to protect this and then have my last term, which is 4, when your m is equal to 4. So I'm going to have minus 1 to the power 4 plus 1 into 4 squared plus 2 into 4. Then I'm closing everything with AMA brackets so then I can follow through my thinking. So let me just simplify, okay? So remember I said in this question you are being tested so many things. You are being tested the ideas of the laws of operations and also exponential laws, okay? This is going to be equal to the first expression, minus 1 to the power 2. So you're going to have minus 1 to the power 2 into 1 plus 2. This is applying our laws of our operations. Okay, so now this is going to be 1 into 2. So I am protecting this thing. And then I'm going to move to the second expression. The second expression is minus 1 to the power 3 into 4 plus 4. I wanted to highlight something so that when you are doing these things, you must be aware of these things. I'm not going to redo the question, but what was interesting for me, what I wanted to highlight for us was minus 1 to the power minus 1 to the power 3 and minus 1 to the power 2, and then you'll come across minus 1 to the power 5. Okay, when it's negative number to the power odd number, because 3 and 5 are odd numbers, you are going to get a negative number. Okay, when it's when the power is raised to 2, your negative number is going to be equal to positive. So when you are calculating this question, here you're going to have negative 1, here you're going to get positive 2, here is going to be negative 1, and then if you've got negative, let's say you've got another one which is negative 1 to the power 3 is 3 to 5. 4 is a positive number, so you're going to get 4 is an even number, so it's going to be equal to 4. So this is just going to be equal to positive 1. So that's what I wanted to highlight in this question. I'm not going to redo it. Okay. It was just a great opportunity for me to highlight exponential loss when you've got a base of a negative number. Okay, here's another question. I am not going to go through this question. What I'm going to highlight here is when you are substituting. Okay, when you are substituting, the substitution is saying you are starting where your k is equal to. You are starting where your k is equal to 2, and then you end where your k is equal to 9. That's the basic stuff. So it can be 2, it can be 1, it can be 3, it can be 4, it can be 5. It depends. Read your question as clear as possible. So here, your first expression is going to, you're starting at 1. So you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're going to be substituting for all of those. So your first one, I'm only going to substitute for the first one and the second one. So this is going to be your k is equal to 2 because you're starting at 2. 2 plus 1 divided by 2, that becomes your first term. Your second term is going to be equal to, you are doing this thing in an ascending order. So this is going to be equal to 3 into 3. This is going to be equal to 3 into 3 plus 1 over till your k is equal to 9. So we are going to stop where your k is equal to 9. So you're going to have 9 is 9 into 9. 9 plus 1 divided by 2. So this is going to be divided by 2. Okay, so that is going to be your last term. Okay, so you can go ahead and simplify it. Okay, I'm not going to go through any simplification. If you think you've got problems with simplification, that means you need extra help. Okay, so I'm going to leave this question. Okay, right. So there is this concept called factorials. There is a definition of a factorial. Somebody last week, we what exclamation mark. It's good for you to remember that it's an exclamation mark, but this exclamation mark has got a mathematical definition. This exclamation mark, it is denoted as the factorial of a natural number. Remember, the natural numbers are those numbers 0, 1, 2, 3, 4, 5, until. So those are the natural numbers. It is a factorial. It is of a natural number. It's a product of all natural numbers that are less than or equal to that number. Okay, so here is the factorial. Here is the definition in a mathematical terms of a factorial. So you can see my examples. If ever you've got 3 factorial, if you are going to be using this formula, a 3 factorial, we are starting with 3, you are descending. So it's going to be 3, 2, 1. So you multiply those. So you're going to have 6. Same applies up 2 factorial. 2 factorial, it is starting with 2. And then the next number descending is going to be 1, which is going to be multiplied by 1, which is it's going to be equal to 2. Same applies with 5. So this is just the definition of a factorial. So now we are saying the definition in a generalized way. Here is a definition of a factorial. So what it means if ever you are looking for 9 factorial, your n is equal to 9. So you're going to have 9 multiplied by 9 minus 1 is going to be equal to 8. Okay, so if ever you've got 230, it's going to be 130 multiplied by 129. If ever a city is 99 factorial, it's simply equal to 99 into no, it is 99 multiplied by 98 factorial. Okay, so this is just the definition of this. Okay, so let's make an example of that. So now what is the simplification of this? A simplification of this 7 factorial using the formula. 7 factorial is simply 7 multiplied by 6. So now here, in order to simplify this without even breaking this thing down into smaller nyana components, look at what you have on your denominator. You've got 5 factorial. It means for 7 factorial, you can still go further down. So now you can still multiply this thing by 5. So now it's going to be 5 factorial. Okay, so now it does not mean you can still write 7 factorial, guys. It does not mean 7 factorial is only here. It's only this value. I am stopping at 5 factorial because I can see there is something that I can cancel with at the bottom. So that's why I am stopping here. Okay, you can have 7 factorial can be written like 7 factorial can be 7 multiplied by 6 factorial. It is still 7 factorial, or you can have, it can be equal to 7 times 6 multiplied by 5 factorial. You can stop here, or it can be equal to 7 multiplied by 6 multiplied by 5 multiplied by 4 factorial. It is still the same thing, or it can be equal to 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 factorial. Okay, or it can also be equal to 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 factorial. Okay, it's really up to you where you want to stop. You are being guided by, if ever it's a fraction, let your denominator help you, because you want to be simplifying this thing where you can cancel out. If you've got time, guys, till now we don't have time, you can just write the whole factorial and have 5 multiplied by 4 multiplied by 3 multiplied, but you don't really have to, because this will simply cancel out with that. Then you're only left with 7 multiplied by 6. So your 7 multiplied by 6 is just equal to 42. Okay, if you've got time, which you don't have, okay, if you've got time, you can say, okay, I'm going to write 7 factorial in its full form. So I'm going to have 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. This is 7 factorial, okay, in its fullest form. And then I can also have 5 factorial. 5 factorial, it is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Yeah, still you are getting into what we call a circular argument. You are repeating yourself. In any event, this will cancel out, this will cancel out, this will cancel out, this will cancel out, this will cancel out. You are still going to be left with this. So I'm saying, if you have time, which you don't have, you can break it down into this, and then you cancel out, or you can do the shorter method. So this is the method that we want, because we don't have time. You don't have time. You look what is on your denominator and say, okay, fine, on my numerator, I can stop here. I'm going to have 5 factorial because it is problematic, cancel out, and then I've got a simplified form. So the factorial is helping us to understand the calculations that we are going to be using when we are working with permutations and also a combination. And that's about it. There's nothing wonderful. Nothing about factorials other than Nazor. Here is a permutation. Permutation and combination, there's this exclamation mark that we have given a mathematical definition. We are saying this exclamation mark is none other than a factorial. Okay, that's the name of the exclamation mark. And then that is one of the critical aspects that you need to know when we are working with permutations and combinations. Okay, so what does this mean? Why should we be bothering ourselves with this? Okay, when we are talking about permutation, is when you want to be arranging. Okay, it's all about arranging a certain way of arranging objects. Okay, so now when we are talking about permutations, we are looking at ways of ordering objects, and then that is permutations is all about the order. Let me get to the definition. So we are looking into these two creatures, into these formulas, when we are talking about permutations and when we are talking about the combination. I-permutation i-formula yakhona uyibona ngo-P, uyibona ngalo P lona, combination uyibona ngalena. What are these? What are these things? Okay, it is important that we understand the definition of these things. Okay, let us start with the one permutation. Okay, permutation, it is an arrangement of object in a definite order. Okay, also, it is a mathematical technique that determines the possible arrangement in a set when the order of arrangement matters. Okay, let's say you've got numbers. Okay, you put those numbers with list, but now kulama numbers, let's say 1 5 4 3 2 8, whatever the list that we have. But in this, we want to arrange these numbers, and then you want to arrange them in a specific order. So there's a rule that needs to be followed. So with permutation, there's an order, everything is strict rules and whatever. So that's when you are applying a permutation. Okay, the arrangement of that list. It can be numbers, it can be words, it can be anything that you want to be arranging. So that's when you are using a permutation, because the permutation is telling you, Guti, if ever you want to be arranging this word, let's say Ugasamba, my surname, you want to be arranging Ugasamba in a specific way, so then maybe it sounds like Ugasamba, it is GCA, that's an order. So then we can be able to call Ugasamba in a Xhosa way. But if ever maybe you want to call it in a different language, some people are going to say it's Xhosa, or they are not even going to call Usi. So there's a special kind of arrangement from that language perspective. But if ever the rule is specific, I am asking you guys to say, please, can you pronounce my surname as Gasamba? So then the order is, we start with G and then it's C. There's a specific order that you need to follow for you to be able to call my name Gasamba and order the alphabets. You are going to be using a permutation. That's all it's all about. However, with a combination, it's like I'm giving you how many letters? Let me see how many letters is my surname. It's 1, 2, 3, 4, 5, 6, 7, 8. It's 8 alphabets. If I'm saying I'm giving you all of the alphabets of my name, I say, arrange it in any way that you pleases, as long as I've got those alphabets. Then you decide into what I don't like the way you C when it's close to G. I man, I cannot even pronounce Ugasama. Let me take you see and throw it at the end. So then it sounds like Gasamba. At least I can pronounce this one. Gasamba. It's up to you. Then that is combination. A combination is saying I'm arranging these words. I don't care about the order as long as all of the alphabets are there. So I am going to be applying a formula of combination. Okay, so now a difference between a permutation nama combination is about le enye inomthetho, le enye kwenziwa noma yini, does not matter. It's about selecting. The one of a combination, you must look at the keywords now. When you are reading a question, the keywords are speaking about, you are selecting. There's no order. When you're reading the context, there's a certain rule that you have to follow. Then you know we are going to apply a combination. When it's all about the order, it is permutation. So here's the formula. The formula for the permutation. It is saying the number of permutation of a set of an object taken R at a time is denoted. This is the formula. And then what it basically means is saying the number of permutations of an object, that means the total, that is your pool, the total number of objects, and then you are going to be arranging this thing. There are objects out of this n. So R is out of the total. Let's say the total number of alphabets is 8. And then if ever I want to arrange these 8 alphabets into like into 7 into 7 alphabets, that means I've got my R. Okay, my R will be the 7. It is 7 out of the total. So that's what this really means. So this is a formula that you use for a permutation. A permutation is all about the order of the arrangement. It matters how you apply the thing. So here is a formula. Okay, here's is an example. The example is saying you need to evaluate this. So in order to evaluate this, you need to get your formula. So your formula is saying you've got P R N is equal to N factorial divided by N minus R factorial. This is a formula of length permutation. What is your N here? Your N here is equal to 4, and your R is equal to 2. So now you have broken down your components. You come and substitute them. So now you've gone have P 2 4. So this is equal to your n is 4. So you've got 4 factorial divided by your n is 4 minus your r is equal to 2 factorial. Okay, let us simplify our denominator. So you are going to have 4 factorial divided by 4 minus 2, it is 2 factorial. So this is not arithmetic, guys. The minute there is a factorial, you cannot just say 2 goes how many times to 4. You need to follow the rules of factorial. So now you've got your numerator and your denominator. So what we can do, we can say, let us look at our numerator. Our numerator, we can write it as 4 multiplied by 3 multiplied by 2. We can stop here. We don't want to write the full thing. And then because why we want to stop here? Okay, let me lose my multiplication, guys, because I don't want to throw you off. Okay, so here we've got 2 factorial. I just want to simplify. So 5 multiplied by 3, it is equal to 12. Okay, so this is how you are applying the basic calculations of you're right? 4 multiplied by 3 or 12. And then that is permutation. But it is just basic calculation. We want to see these things in a context. A combination, I've already given you example a combination, but let us look at the definition of a combination. A combination is a mathematical technique that determines the possible arrangement in a collection of items where the order of selection, it does not matter. It does not matter if ever you've got letters, 8 letters of Utsasamba, how you arrange it does not really matter. Okay. Maybe I can say I'm giving you 7 letters of Utsasamba. I don't give you one and say arrange it. Does not matter how you arrange it. So you are going to be using a combination. Okay, it's all about selection. It's a selection in any order. Understand that? That's what makes a combination distinct from Ilento, from this guy, from Ilento, a permutation. So you need to look at these things way too, so that you can be able to contrast each and see what is the difference between each. So here is a formula. The formula corner. This one, it is the same as the one of a permutation. Mara, this one is going to have R factorial at the bottom. Okay. So let us look at what is important is for you to be able to understand the difference between the two formulas. Now let us do Ilento. Let us get an example of Ilento combination. What is the formula? If formula ET, you've got combination Rn is equal to n factorial divided by n minus 1 factorial r factorial. Okay, so now let us, what is our n here? Our n is equal to 9 and our r is equal to 5. So what you do, you take this and then you substitute it. So you're going to have 5, 9. So my n is 9, so you've got 9 factorial divided by 9 minus 1 factorial. What is my r? My r is equal to 5. So I've got 5 factorial. Okay. So I've got 9 factorial divided by 9 minus 1. It is 8 factorial, 5 factorial. Okay. So here you just want to, am I right?
Ma'am,
Irongo.
Minus 5.
ma'am,
Irongo.
Very wrong.
These are the common errors that you find. Bese iyakulahla question at the end. But with mathematics, when we are marking, we do what we call follow-through thinking. we follow through the way you are thinking, even if you are not thinking according to what the question was asking you. We are just looking good, okay, when now you have made your own interpretation in that question. If you have decided to use that interpretation, are you following the rules of that discourse? It does not matter whether it's way out. So that's why many people from the metric, you find them good, they are passing in maths, and then they wonder, good, how did I pass on earth? It's because you have applied a wrong discourse, but you have followed the rules of that discourse. So this is going to be equal to 5. Ne? It's 4, ne? So you want to simplify. To simplify here, you said, okay, fine, I've got my numerator and my denominator. Let me see, Uguti, how can I simplify here? So I can say, let me look at my numerator. Let me deal with my numerator. I can write my numerator as 9 multiplied by 8 multiplied by 7 multiplied by 6 multiplied by 5. I'm going to stop at 5 because I've got 5 factorial at the bottom. Not that you cannot proceed. You can proceed and have 5 multiplied by 4 multiplied by until 1. But because we have only to know 5, why should you bother? And then this is going to be equal to, I can write ulento 4. 5 is going to be taken care of this. Let me write 4 factorial and break it down because it is very few product. So I'm going to have 4 multiplied by 3 multiplied by 2 multiplied by 1. I'm going to multiply 5 factorial. Okay, why? So this I'm going to cancel out, this I'm going to cancel out, and then I'm going to do what? U4 uyahamba uyalaphayana kayi-2. This and this goes to 6. Then I can sipe on my denominator. Then I know what my answer here is going to be equal to 9 multiplied by 2 multiplied by 7. Okay, so this I can easily get the calculator, or if my brain cells are sharp, you can just get an answer which is just going to be equal to 126. That is an answer of that if ever you're using a formula. So here, the reason why I've used this example, I just want to take you through the calculations. That is the critical aspect of this topic. You need to know how to calculate, okay? How to do a substitution, how to apply a formula. That's it. We are going to go to a stage whereby we need to think a little bit further, okay, whereby we are doing our word problems. That is the most problematic area, but here it is just a practice. Look at some more exercises and see if ever you can do a practice of doing our calculations only. Okay, now let's come to the real stuff. The real stuff, it's okay, fine. What is the difference between a permutation and a combination? Okay, from a mathematical perspective, I can tell the difference if I've got two formulas. Not a problem. I can see, I mean, they are evident. Le enye ino C, le enye ino P. So I can easily put this thing under a permutation and get a lot. That one is a simple, exercise. But how do I tell the difference if I've got a context? Okay, if I've got a context, we are saying a permutation, it is the number of ways to arrange things. Okay, you are arranging izinto. I-arrangement ke inomthetho ke. So the keyword here kuma-permutation is about arranging. Okay, uku-arrange vele u-arrange nje, u-arrange because ufuna izinto zihambe nge-specific order. Otherwise, why would you arrange? Why would you arrange izinto if ever there is no order uyifunayo? Otherwise ungaziyekela zihlale zimaxhaka-xhaka the way zingakhona. Arrangement, you are following an order, that is permutation. So look at the question and look for anything that is saying arrange this, then you know good, oh, I need to bring in a formula of permutation. Combination is all about choosing. You are just choosing or selecting. I'm just giving you keywords that will help you to think, oh, I need to be thinking of a combination. So now a combination is saying you are just choosing or selecting. Okay, so you know what that combination. So combination akunamthetho lapha, there's no order. Okay, you can arrange izinto noma uzenze kanjani, beka nje ilist yezinto. It does not matter how, if there's any rule that you need to follow, any order. Mara permutation inomthetho, the order matters. There is a specific order. The minute when you are reading a context, uyabona ukuthi there has to be an order here that needs to be followed, then you know ukuthi you need to use a formula of permutation. If there's no order, then you do combination. Okay, ilento permutation, most of the time I'm just giving you my examples and throwing them around. Ilento permutation is about the list. The list needs to be in a specific order, so you use ilento permutation. Ilento combination is all about groups, because groups groups is a collective. There's no order there. So now if you look at those things, then you know what, oh, the minute I groups, I know what is combination. So I'm just throwing to you the keywords that will help you to decontextualize problems that have got something to do with a permutation. Ne combination. Here's a question. Iti, in how many ways can 5 runners finish the race? Okay. I mean, I believe we've ran esikoleni baye basforsa to run sport. So we know to finish the race, there are places. Guno number 1, guno number 2, guno number 3, guno number 4. There is an order there. Okay, so it is important we order. Then that will be a permutation. You can also compare a permutation during my time when I was doing not in metric, I think about standard 7 or standard 8, somewhere lapho. It was important to be number 1 at classing. The way that you would be report beyenzwa kuthiwa number 1, kuno number 2, kuno number 3, that you would use the permutation in the old syllabus, because it was important to ubani number 1, no number last ofelayo, you understand? So that thing, there needs to be a truth and reconciliation for that kind of curriculum, because other people really felt to our number last, you are really a slow learner. But things have changed now. In the curriculum that we are using now, aguna number 1, aguna number 2. We understand? So that one you can say is more of a combination, because if you compare it with an old curricula, in the old curriculum, number 1, number 2, number 3, number 4. So good, this one, there's no number 1. If you are passed as parcela, level 6 or level 7, whatever. So aguna number 1 number 2. So in the olden days, it was important to be number 1. So that's where we got confidence, people like us, of feeling good we can do maths, because we were number 1, so we needed to keep the position. So that is, think of that when you're looking at permutations and combination. Think of the everyday kind of examples that you said, oh, permutation lan, oh, lana ilento i combination. Okay, here's another example. In how many ways can a president and a vice president be chosen from 20 people? Okay, without even looking at the answer there. For ukuthi ube president, there is it's an important role. There's an order here. The roles are not the same. For you ukuthi ube uRamaphosa, even umholo, you get the package emnandi, so you've got different roles. So there is an order that is important. Who's this guy that I loved so much that has just resigned as a deputy? Udidi Mabuza. I loved this guy because he did not bother himself at all. He was just chowing our money. So he had his own responsibilities, which are lower than Uramaphosa. So there's an order there. Okay. So the order is important when it comes to that kind of a context. Hence, if ever you would do a calculations, I mean, how many ways can a president and a vice president be chosen from 20 people? You would use Ilento a permutations formula. You have to make a decision as a mathematician. No one is going to tell you to use a permutation. That's why some of you felt good. I am sharp at this chapter. No, it's very easy. Very, very easy. It just like you need to understand what does it entail. Here's another example again. You've got a group yabantu abayi-10, ne? A group of 10 people, then une 20 rand, une 10 rand, and then une 5 rand prices will be given. How many ways can the prices be distributed? I'm going to throw it back to you guys just for a few. We're not going to have time of doing our discussions, but just by looking at this question, would you say it's a combination or a permutation?
Combination.
It's a combination. Why?
Yes. Because there's a group of people.
Because of the group.
Permutation.
And order doesn't matter.
Okay, who's a permutation, Otene?
I think because price will be given, like for the first prize you get $20, and then maybe second prize $10.
Yeah.
So that's why I think it's a permutation. Like
Okay.
there is an order, like first, second, and third prize.
First, second, and third, because you can even see the prizes. You've got 20, 10, and 5. You understand? So, Labantu, those who said the combination, they just saw a group. I mean, for the fact that you see group, you're just told just a group. It is 10 people. It is not just like a collective, a community. It is like you are told what is a group by 10, but within this group of 10 people, there is a price that means, and then the price we have on what is 10, it is descending. So it seems this is first, second, and third. So there's an order. Okay, the keyword here is a price that needs to be given. So there's an order. So your R here is equal to 3. Okay, your R it has to be 3 because now there are 3 people that needs to get this price. So now this one is a permutation because the order is important. So it is 3 people out of 10. So your N is equal to 10, and your R is equal to Batinina. Your R is equal to 3 because there's 3 prizes. It has to be given to 3 people. Okay. Let's look at this one. I'll just do this one quickly. In a group of 10 people, 3 5 rand prices will be given. How many ways can the prices be distributed? Lana, I'm price is I 3 for Imale 1. 45 rand. So it does not matter who is number 1, who is number 2. It is just for 3 people. So we can, because they're all going to get 5 rand. So it does not make any difference. Lana would okay, who is number 1, who is number 2. Think of a curriculum that we are having currently. If level 7, you level 7, it does not really matter nizopasa. But in the olden days, in my days, if ever number 1 or number 2 or number 3, it is very important. The order was very important. So this one is a combination. Here, a local school board with 8 people needs a committee with 3 people. Okay, how many ways can a committee be formed? Also, this one, when you are just reading it, okay, you've got a school board, it's 8 people. It's a committee. A committee is just a group of people that needs to be formed. It's a committee of 3 people. Okay, so kule 3 people akutshiwo into ukuthi this one is going to be a chairperson, this one is going to be a secretary, this one is going to be what. It is just 3 people. So now this one, there's no order that is important. So this one can simply be put as ilento. It can be put as what you call it, as combination, because there's no order, just from reading the story. Okay. Here, you've got a local school board with 8 people needs to form a committee with 3 different responsibilities. So I would think here, board uzobe une-chairperson, a secretary, and omunye a treasurer. You understand? So those are different responsibilities. So the order is important here. So here you would use a permutation. It is a context of a permutation. So you can compare the two contexts. You can see the difference. I mean, we don't really care. There's no responsibility. There is no order. Here there's an order, because when a treasurer, there are rules, there are responsibilities which are different from the levels. Each person in a role is different. So there's an order here. So you would use IPEMU, you would use what you call or permutation. Okay. So here is an interesting one. Okay. Nancy Indabanza. Let's read the story. What is it? A local school board with 8 people needs to form a committee with 3 people. Okay, so there are 3 people here that needs to form a committee. So already at the back of your mind, you said, okay, fine. Here, the total number of these, your N is equal to 8. You're just thinking at the back of your mind, that is total. Your N is equal to 8. Okay, and then here, and then, but now, ufuna ukufoma a committee of 3 people. That is your R. Yeah, so you this is R out of the total. So your R is equal to 3. So you put that at the back of your mind. Okay. However, in this context, there is more information. They are saying if 5 of the members are girls and 3 of the members are boys, it is still detailed information of these 8 people. 5 plus 3 is equal to 8. It is just they are giving you details of, so then you can have a picture. You can see 5 girls here, and then you can see 3 boys. So that is the total school board. Yeah? So now, how many, okay, how many ways can the committee be formed if 2 must be girls and 1 must be a boy? Okay. So here, just by reading the story, there is no order. No one is getting any responsibility or any order. It's only about the people who are there. It's just the genders. Okay. So there's no order that needs to be followed. So we are thinking of a combination. However, there are 2 variables here. Okay. Remember in the previous example, there was no variable. It was just the people. But here we've got 2 various variables. We've got N of equal to 8. Okay, the total number of people, our total is equal to 8. Okay, what is this total made of? This total is made of 5 girls. I'm going to use Uchi. Okay, and then how many boys there? And then you've got 3 boys. Okay, so there are 2 variables, but they are still the total. It's just that imagine they are just putting these things according to each gender. We're not talking about the order. We are just talking about each gender. So kunabafana by 5 girls and 3 boys. Okay, that is our total. So this is our N. Okay, this you can see it as our N. This is our N. Okay, so remember we are going to be choosing a committee of 3 people from this. That is your R. What is your R? Your R is saying now you need to be choosing. Okay, how many can be formed? You want to be choosing out of 5 girls, you want to be choosing 2. That is selecting. Can you see where ilento where a combination is coming into play? So how many that can be chosen? So now you need 2 girls. So now you are going to be having 2 girls, okay, and then 1 boy. This is your R. This is choosing from that. Okay. But now the question is, so what? Okay. So what? What do I do with this question? I know the formula for a combination because I know I'm going to be using a combination. A formula combination, ETN CR is equal to n factorial divided by n minus r factorial r factorial. Okay, so this is the basic formula of a combination. I know I'm going to use basic formula, but I've got 2 variables here. Okay, so now we go now and think about principles of counting. So if you look here, there is this thing called and. You've got 2 girls and 1 must be a boy. In counting principles, and means you multiply those 2 variables. Okay, so now what it means is you are going to have a formula for the girls and a formula for the boys using the formula of what is this one, a formula of a combination, but because you've got u and you are going to be multiplying. Okay, if you come across a question which is going to have or, you are adding, but you are not going to go there today. Today we are going to be using u and. Once there's 2 variables, okay, maybe there's an apple and a banana. So there are 2 variables. That means you have to multiply those 2. So it means you go here. Here you're going to have a formula. Your formula here, your n here is going to be equal to your 5. Your n here is your 2. Here your n is equal to 3. So your n is equal to 1. You've got 2 variables. Sometimes you would have 3. There is an example whereby you've got 3 variables, whereby there's an aeroplane, there's an energy, there's a something. Those are 3 variables, 3 companies. Here there's 2, there's a girl, there is a boy. Those are 2 variables. So you need to have a formula of combination for this one. So according to the formula, you are going to have your n. You are going to take this part. This part, your n is 2. Okay, is 2c. Your r. This is your r, guys. This is your r. This is your r. This is your r. So your r is 2. Okay, it's 5. This is 5. Here you've got 3, and then this is going to be c. Your r is 1. Okay, so now you've got those 2 because it's and, which is multiply. So it means you are going to have your answer there. You are looking for the number of ways is equal to 5c2 because it's and, because you've got 2 variables. You're going to multiply by 3c1. So the formula here, you are going to be applying this formula. So with this part, you are going to be having 5 factorial divided by 5 minus 2 factorial, and then your r is your r there is 2 factorial multiplied by, here you are going to have your 3 factorial divided by 3 minus 1 factorial multiplied by 1 factorial. So now you have decontextualized your story. Okay, so when you get questions which are looking like this is how you would think. Okay, whether the story is talking about aeroplanes or the cars or the apples or the bananas, look at the varying things, the variables. Do you have apples and bananas? Those are three. Is it two or three? It does not matter. This is how you attend the question, which looks like this. So here it is just simply a simplification. So you're going to have 5 factorial divided by 3 factorial, 2 factorial, multiplied by 3 factorial divided by 2 factorial, 1 factorial. Yeah. So after you have done that, you just simplify. I am going to need some space, guys. There is a recording, so whatever I've already done, it's already been recorded, so you don't have to worry that I'm erasing this because I need space. I don't want to go and start on a new page because I want you to follow my thinking. So here on your numerator, you are going to have uno 3, uno 2. On your numerator, you can say I've got 5 multiplied by 4 multiplied by 3 factorial. I can stop there at 3 factorial because I know I can see I've got 3 factorial on the bottom. I've got 3 factorial. I can just multiply 2 multiplied by 1. This is multiply. Yeah? And then multiplied by, on my numerator, I've got 3 factorial. So let me write 3 factorial as 3 multiplied by 2 factorial. And I'm going to divide by 2 factorial. 1 factorial is just equal to 1. So this is equal to 1. So 3 factorial cancels this. Then 2 goes here 2 times. And then here 2 factorial cancel out. So I've got 2, 3. So I'm going to have 5 times 2 times 3. So I've got 5 multiplied by 2 multiplied by 3. So how many ways can the committee be formed in with 2 girls? So it can be 30 ways. There are 30 ways that you can combine abafana namantombazana in a committee. Okay? So you must always have a combination of 2. Okay? It's a boy or a girl and a boy, girl and a boy. So you've got that variation of those 2. They need to be there. Every time you select, you must select from the girls, you must select from the boys. That's why we are saying this is a combination. You are selecting. We don't care about the order, whether it's tall or short or whatever. We are just selecting from the group of girls, a group of boys. We want a combination of the 2. Every time you pull out 1 from the group. So hence this is a combination. Okay. Let's look at another example. Here is another one. Okay. I don't know what was wrong with me here. I don't have enough space to write. Okay. I don't have enough space. Let's think about this one more time. Okay. A committee of 9 people is formed from, okay, 4 teachers, 5 doctors, and 6 lawyers. Can you see in Toguti here? You have the same scenario as the one of the previous question. So now, you want to see a committee is to be formed from, so it's 4, it's 5, and it's 6. Okay, so if a committee members of each profession are to serve in the committee, how many ways can it be done? Okay, so now you want to select 3 members from each profession. What is it that you want? Without even going anywhere, once you say you want to select, I mean, that's not what it's saying, but that is what is implying. If members of each profession are to serve in a committee, okay, if they are to serve in a committee, how many ways? Okay, so there's no order here. We just need three members of each. Okay, so it means now of each profession you want 3 members of each committee. That means your R is what you are choosing from. So now your R is going to be equal to 3. Okay, that's what it means. Your R is equal to 3. And then here, what is your N? Your N, you've got the N for utichara. Okay, you've got your N for your doctors, you've got your N for lawyers. Okay, so here, look at the previous question. Here there are 3 variables. Kunabo tishara, kunabo doctor, kunama lawyers. In the previous one, you had the girls and the boys. Okay, so now you want to see how many times you can do that selection. So you already know what, oh, I'm going to be using a formula of a combination because there's no order. But I've already, from reading the story, I know what I need to select 3 members from each committee or from each profession. In the previous one, you had to select in the previous one, you had to select 2 girls, okay, and then 1 boy. Here, it is 3 for each. So R is constant in each. So now remember, this is a combination. We've got 3 variables. So we are working with the combination, and then it is 4 teachers and 5 doctors and 6. So there's end. Now you're end law. End ukhuluma multiplication. So it means you're going to be multiplying. So now which formula are you using? You are going to say here, because I've already done the analysis, your answer here is going to be your C, your R. Remember we said iafana. Your first one, abotishara, your N is 4. So I'm using this formula, which is N. This is the formula that I'm using. Okay, because now this is a combination. So we are multiplying about doctor. About doctor, you've got 5 doctors, and then remember OR way to it is contents. Is 3 members of each profession. Okay, and then multiplied by, you've got ilento, you've got lawyers. N is 6 for lawyers, and then you've got 6 ulento to 3 for each profession is the same. So now you've got this. So what follows here is to substitute into a formula. Remember, what is a formula? The formula is saying you've got N factorial over N minus R factorial. Okay, R factorial. So now you would substitute for this one on the formula, substitute this for this formula, substitute this for that formula. Okay, I'm not going to go through that because I just want to leave you with the thinking on how you can decontextualize these stories. Okay, let's look at this context. Okay, find the number of ways 2 prefects can be selected from the class of 15 students. Okay, here can be selected. Remember, selection is all about the combination. I already know this is a formula I'm going to be using. Okay, and I mean, just by reading the story, I can see Guti order. I'm just selecting 2 prefects. Okay, there's no order, but that selected is already telling you what you are using combination. So is from a class, your N is equal to 15, and then your R is equal to 2. Okay. So this is going to be your 15, and then your R is equal to 2. So you can go ahead and substitute into your formula, and then get your formula is this is going to be equal to 15 factorial divided by 15 minus 2 factorial, and then your R is 2 factorial. So this is going to be 15 factorial divided by 15 minus 2, it is 13 factorial, 2 factorial. This simply, you move this side, your numerator, you can simplify it and say, I've got 15 minus 14 multiplied by 13. I can stop at 13. I don't want to proceed. I do have my 13 there. So I've got my 13 factorial. I'm multiplying this thing, 2 factorial, it is 2 multiplied by 1. So my 13 factorial cancels out with this. And this is just equal to 7. 15 multiplied by 7. 15 multiplied by 7 is 105 ways. Me? No, I was saying the
Yes.
answer. All right. Okay.
Ma'am,
Yebo.
I just wanted to ask with the previous questions, right? I'm a bit confused with permutations and combinations. When there's a word, like, is the keyword selected with combinations? And also I wanted to ask, my second question is, permutations, does it mean that it has to be specific? The question has to be specific in order for me to figure out my formula?
Remember, so far the questions are not specific that which formula you should use, but you are just reading the story and see. For permutation, in your back of your mind, you must know that for permutation there's a specific order. You understand? Like the one whereby we're talking about my president. My president, you know, if you've got a president and a vice and a deputy president, those are different roles. There's an order there. Then you already know it's permutation. We understand.
Okay.
So with the rest of the questions, you can just have a feel. Good here, it's not important of the roles or the order. Good, this one is got the higher order or the level order. It's just that you are just selecting or selecting or doing what now? Or combining something like that. Am I making sense?
Yes.
Okay. I mean, look at this one. This one, you are just asked to find the number of ways 2 prefects can be selected from the class of 15 students. Even if that selected was not there, you can already see that there is no order there. You just need 2 prefects out of 15 without even having without having the keyword to selected. So don't let these keywords abo selected nabo arrange to make you already quickly want to run to permutation or to a combination. Read the story and see if ever is it important to have an order here. Because sometimes I can say if I want to select a president and a deputy, I can use a word selecting a president and a deputy. It does not mean that is a combination because there is a selecting, but because of the whole scenario, the deputy has got a different role. There's an order there. They're lower than the president. So don't let the keyword to develop, don't develop misconceptions around these keywords, but they are there to help you to, oh, is there an order? Ask yourself, because the first thing that you would think about, you would say, oh, this one is a combination, but is it really a combination? Is there any other thing that is told by this story? Ask yourself those further questions. Okay, here's another one. This one is saying, further, the number of ways a committee of 5 consisting of 3 males and 2 females. You can already see here, gune committee of 5. There's a committee of 5, Mara, you are giving more information. Gune committee, Lena, there are 3 males so there and 2 females, so there are 2 variables. Okay, there are still this is totaling to to 5. Okay, and then they can be formed from a club consisting 8 males and 7 females. You are selecting 3 out of 8. So now what does this mean? Definitely it is a combination. Okay, there is no order here. It is just that you are given 2 variables. Okay, what is the total? Your n here, these 2 are your n. So these are your n. So your total n, your males is n. So now your total, you've got 8 males and your 7 females. This is your total because you are selecting a committee of 5 from this total. Okay, from this total. So now you are selecting. So this becomes your n. So this is your n. So now you are selecting 3 males. So now you've got 3 males and then you've got 2 females. So remember when you are selecting from that, this is that. So now you, every time when you are pulling out, it is end. Remember we said an end is saying you're going to be multiplying. Okay, so it means now you've got 2 variables, you're going to have 2 formulas. Okay, so now those 2 formulas, it is C, your R is 3, okay, your N is 8. Here you've got your N is 7, your R is 2. Okay, so now what you do here, you just plug this thing into your calculator. So it you calculate. So you're going to have 8C3 multiplied by 7 combination of 2. Okay, without getting into details, get the combination thing. So this is going to be equal to your 8 factorial divided by 8 minus 3 factorial, 3 factorial multiplied by your 7 factorial divided by 7 minus 2 factorial multiplied by 2 factorial. I am not going to do the full calculation. I just want to see how to show you how you think up around these. Okay.
Before we go on, I have a question. The first exercise, the first example that we've done, where there's three boys and 3 girls and 2 boys, the very first one, the answer that we got was 30 ways. Ne? I'm confused because when I try the calculation, I get 60 ways. So like I don't understand what I'm doing wrong, because the way that I've calculated it was 5, like from the second step. I get you first substitute into the original formula, and then from the substitution, 5 times 4 times 3 factorial, so that 3 factorial can cancel out with the 3 factorial at the bottom. I have.
Are you correct here? Do you have this step correct?
Yes, this I have. I get it. It's 5, the bottom one, the next one, 5 factorial divided by 3 factorial multiplied by 2 factorial times 3 factorial divided by 2 factorial times 1 factorial. This step I have. The next step. So I said 5 factorial, like when I not decompose, I just said 5 times 4 times 3 factorial, so that the 3 factorial at the top can cancel out with the 3 factorial at the bottom. And then the second one, I said 3 times 2 factorial, so that the 2 factorials can cancel out for the second.
So do you have to multiply by after 3 factorial on the first one? Do you have this one?
So for the first time, I have 5 times 4 times 3 factorial, and I ended there. And then I divided by 3 factorial times by 2 factorial, so that the 3 factorials can cancel out.
All right. Okay. Let's go to the second expression.
It's 3 times 2 factorial, so that the 2 factorial at the top can cancel out with the 2 factorial at the bottom.
Yeah. Okay.
So the next step, I have 5 times 4 that's left at the top multiplied by 2 factorial, right?
Multiplied by?
5 times 4 divided by 2 factorial. For the second time, second term, I have 3 factorial divided by 1 factorial.
3, not factorial, 3 divided by 1.
Oh, that's why I was wrong.
I get you, this one, you are done with factorial. So you say hambi,
Yeah. Okay, this is where I went wrong.
Yeah.
Okay. Thank you.
Sure.
Okay, let me just calculate it times 3. So it's 5 times 4, get 20 divided by.
Please please mute yourself.
Oh, sorry.
All right. Let's see if ever we can see the thinking. It into this question I was going to, I've already have the answer for you guys. I'm not going to go through, but let's see what's happening here. Out of 7 women and 9 men. Uyabona ukuthi already isilungu siyakutshela out of. So this means this is your N. So this is your N. Out of this is your N. Okay? Consisting a committee. You want to do a committee of 3 women. I need a different pen. You want 3 women and 4 men. This is your R. This is your R. Okay? Is to be formed. Okay? In how many ways can this be done? And the first question, any woman and any man can be included. Guys, can you see story line? Story you've got 2 variables here, women and men. So however, you are told any women and any men can be included. You are using combination, and then there's this, so you're multiplying. So what is a total? So now we've got a total of 7 women and 9 men. Okay, so this is just your N. So what is it that you want to select from this? You want to select 3 women and 4 men. Okay, so this is just your R. So you've got 2 things, and then this is a combination. So you already know what you are going to have C. This is going to be 3, 7. This is going to be multiplied by. So this is going to be equal to 9 C4. So you can go ahead and do your substitution. I just want you to see these kind of questions. So here is the answer. You can just have a look on the calculation, and then I want to come here. Nazo izinda.
Ma'am,
Question.
Is
I
it
don't have your question.
4,000
Because I'm still hello. 4,410 ways.
Okay. Yes, ma'am.
Yeah. I don't have your question paper, but I stumbled and I looked and I got the question paper somewhere because I wanted something that is going to speak the whole language and the speak whole story. So then you can see good agnanto etusayo lana. Just have to see the common kind of way of thinking. Here is story sakona. Let me see. Okay. You are given a story here, but an investor has decided to purchase shares in 3 companies. There are 3 companies here. One is engaged in aerospace activities, other is in energy, and is involved in electronics. So you can see what there are 3 variables here. Okay, and there's end. You already see what is combination. This is just a story. Read and then say, after some research, the account executive of a brokerage firm recommends that an investor consider stocks from 5 aerospace companies, 3 energy companies, and 4 electronics. Yabona manje sesiyabona what is the total. Okay, you've got a total here. Just looking at the whole scenario, you've got a total. Okay, you've got a total of you are selecting from, you understand, This is just a selection from. So from, it means now this is a total. You've got 5 aerospace. I'm going to write arrow like this. And you've got 3 energy. And then you've got 4 electronics. I'm writing like this because kunabo iabaningi. Okay, so that is the total that you're having. This is the story, is scenario. So now you can see what is happening. Let's come and answer the question. The question is saying now, in how many ways can an investor select a group of 3 companies from the account executive list? Okay, already awubona uselect. Akukhulunywa nge-order ukuthi hey, this one must be the first. No, select already is telling you ukuthi hi man, this is a combination. Already I'm thinking of combination. And if I read the story further, it's not talking anything about indaba zama order or the special arrangement. You just have to select 3. So it means now you are selecting the group of 3 companies from the list. So it means now your R, okay, your R is 3 for here, it is 3 here, it is 3. So your R is common here, okay. So you want a group of 3 companies from the account executive list. So you've got a list of aerospace, you've got a list of energy, and a list of electronics. So now you need to select a group of 3. Okay, a group of 3. So your R is 3. You are selecting 3, 3, 3. It's a group of 3 from this one, from this one. So your R is common. And then remember, we're saying we are using a combination. So now your formulas here are going to be equal to C. Your R is 3, and then this is 5. Here you are going to have C. Your R is 3, 3, 3. You right? Am I right? Which question is this one? Which question is this one? These questions are similar, guys. These are similar, guys, because I have done, we call it in mathematics, a it's when you create what we call a cognitive conflict. A cognitive conflict is when it's either you deliberately do something wrong or you are unaware, you are interpreting something incorrectly. Is there anything that you want to sit there and say, yes. There's a conflict. Is there anything that is causing a cognitive conflict from my interpretation?
Yes.
Yeah,
I think so.
Yeah.
Because the question says that how many ways can the investor select the group of 3 companies?
3. Yes.
Meaning from the 3 companies, we need to choose one. We need to select one
exactly.
from the 3
because
companies.
At the end, you must
meaning
have
that,
3.
Yes.
Uh-huh.
Meaning
So
that
you must have
our
3.
R has to be 1.
From each, you are going to choose one, so then you are going to have 3. Is it clear, yes, guys? Okay, so now that has caused we call it a cognitive conflict. It is something that that is conflicting in your mind. Good time, man. This thing is a little bit confusing. Why 3? The minute you start having those questions, we call it a cognitive conflict. Once you've got a cognitive conflict, you need to go and ask yourself more questions. Is it true? That's why it's good to work as a group if you can afford to study as a group. So then you can be able to resolve each other's cognitive conflict. Because through cognitive conflict, the other one is able to explain more clearly. So it's a group of 3. You need 3 companies. So it means you're going to be choosing 1, 1, 1. So then you are going to get 3. So now here your R is equal to 1. So you're going to have 1, 1. So here you're going to have 4C1. So remember, this is AND. This is a question of and then it's selecting is already suggesting a combination, because now you've got 3 variables. So now you're going to be multiplying. So get a formula of this, get a formula of this, and then get a formula of that one. Let's see a question from the same story. The same story is saying, suppose the investor decides to purchase in the stock 2 aerospaces. Okay, so now you've got your total. Your total was 5 euro. So you've got a total of 5. Remember, your total is N. Your 5 euro. Okay, and then you've got your total, your 3 energy company, and then you've got your 4 electronics. This has not changed. Okay, but now investor decide ukuthenga 2 aerospace companies. So now you've got 2 aero, and then 2 energy, and then 2 electronics, out of the total of each. So out of 4 electronics, the investor buys 2. So now this is, just by reading the story, is equal to your R. Okay, so there is no, the investors select the group of 6 companies. Can you see? Select the group of 6 companies, 2, 4, 6. 2, 4, 6. That means you've got 6 companies. That's where this 6 means. So don't let it confuse. Go too much. There's an extra information. No. It's not an extra information. It is more detailing, giving a more story to make it look as if it's difficult. This is 6 companies. 2, 4, 6 are going to make up this these 6 companies from the list of 5. And from the list of 5 aerospace, it's still the original information. So now you already know, Guti, this is selecting is a combination. So you're going to be having C 5 2, and then you are going to be having your C 3 2, your C 4 2. Remember, this is a combination, and then it is AND, because you've got 3 varying, and then this 6 is meaning you are adding 2 plus 2 plus 2. You are adding. Okay, so it's AND. So you are multiplying. So going further is for you to substitute into the formula. Woo! That was my last slide. So, okay, guys, there's nothing more. There's nothing less I'm going to say about this. Permutations and combination at this level that we are in. This is all that you need to know. Okay, so what is left for you, if ever you want to understand this thing more, is to do more of my exercises. Otherwise, there's nothing horrible about this section. Yeah, my exclamation marks, and also of that sigma notation. Okay.
I have a question in regards to sigma notation. There was a question that you said we're gonna get back to. I don't know if you said you're gonna go back or if we're gonna look back at it. But there was a question. I've been suffering with that question. But we never went through it.
Yeah.
Yes, that one.
That one you can just evaluate.
Okay.
Minus x is outside. Leave minus x alone. For each, you're going to do this thing 3 times. So it means you're going to have r is equal to 0. You're going to have r is equal to 1. You are going to have r is equal to 2. You're going to have r is equal to 3. So you are going to be substituting this thing 1, 2, 3, 4. You are going to be having 4 expressions. Okay, leave x wabantu ngaphandle akenzanga lutho. So we are going to leave x outside and protect everything inside. Okay, so x is not affected by this, so you put it inside. So now let us start here. So starting here, you are going to have your x. What is your r? It's 0 plus 1 divided by your r is 0, 0 factorial. Okay, plus x to the power 1 plus 1 over 1 factorial plus x 2 plus 1 over 2 factorial plus x to the power 3 plus 1 divided by r is equal to 3 factorial. Okay. And then this one is correct because this is a step. Okay. So you want to, but bafuna 8, that is not correct. So it means you need to proceed and simplify this. So this is going to be equal to x0, okay, over 0 factorial plus x to the power 2 over 1 factorial plus x to the power 3 over 2 factorial plus x to the power 4 over 3 factorial. All right. So already this thing iyafana. This is correct. If you were to multiply this thing, so this is incorrect. Né? Can you see why it's incorrect? Because if you were to multiply by negative x on number 2, you are going to have negative x multiplied by x to the power x to the power 0 over 0 factorial plus x to the power minus, because you are multiplying. I'm just substituting because I want to see if ever this is making sense. Minus x multiplied by x to the power 2 over 1 factorial minus x multiplied by x, okay, to the power 3 over 2 factorial minus x multiplied by x to the power 4 over 3 factorial. Look, this if ever is the same as this one, okay? Usa-check nje your first term. It's minus x multiplied by x to the power 0. X to the power 0 is equal to 1. So this is incorrect. This is supposed to be negative because this is going to be negative. So this is incorrect with the sign. Here the sign is supposed to be negative. So this one is the one which is not correct. Okay. So you can just proceed with simplifying this and check if ever it is going to give you ilento. So here you are going to be having so it means this one is taking us again here. I'm going back here because I want to test, because this one has helped us here. So you're going to have minus x into x to the power 0. Okay, x to the power 0, it is x to the power 0, it is equal to 1. Why? What is 0 factorial? It is 1 plus x to the power 2. What is 1 factorial? Quickly, guys, I've stolen your time. That's why I'm doing this.
It's 1.
It's 1. 0 factorial is 1 in 9. Ne?
I'm not sure.
Yes.
Yeah. And then I'm working from this step, ne? So this one has given us an answer for this one. So plus x cubed, 2 factorial is equal to 2, Anish. What is 3
Yes.
factorial?
Yes.
3 factorial is equal to 6.
6.
6.
Okay. So, number 3. This one is correct. Okay. 0 x to the power 1. X to the power 1. Guys, akunamuntu ongitshelile ukuthi uyabhayiza mabhayizane. This is 1. 0 plus 1 is 1. So this is 1. Okay. But in any way, even if this was, so this one is incorrect in any way. Minus x because of the sign. This one is incorrect because of the sign. So here, so manje, if ever you are looking at this one is correct. Okay. I bet if ever you want to simplify, you'd also find that this one is correct. So now thinking number 2, why number 2 are wrong is because of the sign. Are you clear?
Yes.
Yes, ma'am. Thank
I mean,
you.
if ever you simplify this, I'm sure you're going to get to number 4, ne? Just by looking at it, yes. The common denominator is 6, so 6 is minus 6x squared. The one, yeah. So this one, the one which makes this thing is incorrect because of its sign. This one makes it incorrect because of the signs. So this must be negative because remember, you are multiplying by the negative x, which was outside. Negative x, this one is correct, but here it should be negative, and then this one should be negative, and also this one should be negative. So that's why this one makes it incorrect. So it means you can't run away. You just have to simplify the whole thing, and then you are going to get the answers as you are simplifying for which one which is correct. Happy?
Yes, ma'am. Thank you.
Yes.
Alright, so uyayibona labantu bebekhala ngama-exclamation mark akunanto lana amanzi amancane this thing. It is just that they make it look like it's complicated. Okay, so I suggest that in questions like this, try it and have some group discussions. I know it's difficult. It's difficult to have a group discussion, but there's teams. But now if ever you don't have these writable things, you can't even you won't be able to share your ideas, so it makes it difficult, but it's good to work as a group, so then you can be able to help each other with those cognitive conflicts. Maybe when I into indlela, then you can be able to discuss. I hope you can be able to do those group discussions here from this group and see if ever you can't be working together remotely. You can do it online and have some discussions. That's it for me, guys. I am tired. So, guys, enjoy your long weekend if ever you'll be enjoying it. I don't wish to be you. I hate to be a student. I'm still traumatized by the assessments. So, good luck.
Okay, thank you.
Thank you.
Thanks,
Bye bye.
Martin. Bye.
Bye.
Bye-bye.